We want to take a look at solving quadratic inequalities. We have a quadratic function f of x, where f of x is x squared minus 8x plus 12. We're looking at solving graphically. So we have the graph of f of x given for us. First, we want to take a look at f of x equals 0. On our graph, we can take a look. F of x is equal to 0 precisely on the x-axis, where our graph intersects the x-axis. So we see we have two solutions. The first occurs where x is equal to 2, and the second occurs where x is equal to 6. So graphically, we can pretty quickly get our two solutions for f of x is equal to 0. It occurs where x is equal to 2, or where x is equal to 6. Now, if we want to take a look at where does f of x give a value that is less than or equal to 0. Here, what we're interested in, because it's less than or equal to 0, we're talking about those function values that are below 0. On our graph, we knew from the previous problem that the graph is equal to 0 when x is 2 and when x is 6. As far as when is it less than 0, because our parabola opens up, we must be talking about all that space in between. So our solution to this will be an inequality. In set builder notation, we have all of our values x, such that, well, the x values start at 2. X values increase and until we hit the number 6. And notice our inequality was less than or equal to, so the inequality symbols for our solution also contain the equal to part. We could give this answer also in interval notation. All of the values where the parabola is below 0 on our curve are the x values where x starts at the number 2, increases until x is the number 6. We did have equality. It is less than or equal to. So we will have a bracket where x is equal to 2. We will also have a bracket where x is equal to 6. F of x is less than 0 on the bottom portion, that part in between 2 and 6 on our graph. Now, if we want to take a look at the inequality, when is f of x greater than 0? Again, fortunately, we know that it does equal 0 when x is equal to 2 or when x is equal to 6. But when f of x is greater than 0, really, here is we want what portion of the graph is above 0. For the less than portion, we wanted the part that was below. Well, taking a look at the graph, our function values are above 0, heading to the left of the number 2. But also, it's all the values on our graph that are to the right of the number 6. So from our graph, we see that the portion above the x-axis, that's where f of x is greater than 0. The left part is all numbers that are less than 2. So x is a number such that x is less than 2 to the left of 2. Or x is greater than 6 to the right of 6. These are the two tails, let's call them, of our parabola, because this parabola opens up. We can express these using our interval notation as well. For interval notation, the tail that goes to the left, how far to the left does it go? Well, as far as it wants to go. So from the left, we would start at negative infinity, carries the parenthesis at negative infinity because it will never be equal to negative infinity. We just never reach it. We go all the way until the number 2. Now this inequality did not have the equal to portion, so at the number 2, we would carry a parenthesis. Negative infinity to 2 denotes all values of x that are to the left of 2. We do have our or, which we denote with a union symbol. The right tail starts at the number 6. Starts at the number 6 and increases, keeps on going to the right, as far as we want to go, all the way to infinity. Immediately, parenthesis at infinity, we can never equal infinity, but since we also do not have equality at the number 6, we would also have a parenthesis for the value where x equals 6. So using our interval notation, our solution is all values of x from negative infinity to 2 or from 6 to infinity. Finally, we'd like to take a look at all the values of x that would give me a function value that is less than 12. Less than 12, remember, because this is less than, we're really looking for the values that are below the number 12. On our graph, we see where our function value is 12. We could denote it 2 points. One of them occurs where x is equal to 0. The other point that gives us a function value of 12 occurs where x is equal to 8. So I know where it is exactly equal to 12, at 0 and an 8. When is the graph below 12? Well, looks like it's all the area in between our 0 and our 8. So, in our set builder notation, we would have x is a number where it starts at 0, goes to 8. X is simply a number between 0 and 8. The original function did not have equal to, or the original inequality was not equal to, so our symbols here, x is strictly in between, greater than 0 but less than 8. Also, we can write this in interval notation because we're talking about all the function values starting at 0, going to 8. We do not have equality at 0. We have a parenthesis. We do not have equality at 8. We have a parenthesis there also. So f of x is less than 12 when x is any value from 0 to 8.